Mastering reliability analysis techniques. Only one person holds the key to preventing equipment failures and saving the company millions. Who in an organization is responsible for ensuring that reliability analysis is performed in order to identify and mitigate potential failures, thereby achieving operational excellence by maximizing equipment uptime, reducing maintenance costs, and improving overall productivity? The pursuit of operational excellence. It's a journey, not a destination, and it's one that requires a deep understanding of the intricacies of reliability analysis techniques. Let me take you back to a time when I was working with a manufacturing firm that was struggling to keep their production lines running smoothly. Equipment failures were frequent, and the maintenance team was constantly firefighting to get things back online. It was a vicious cycle, and one that was bleeding the company dry. As we dug deeper, it became clear that the root cause of the problem lay in the lack of a structured approach to reliability analysis. The team was relying on gut feel and experience to identify potential failures, rather than using data-driven techniques to predict and prevent them. Our first step was to gather data on the equipment's performance over time. We collected information on failure rates, mean time between failures, and mean time to repair. It was a painstaking process, but one that was essential to understanding the underlying patterns and trends. As we analyzed the data, we started to identify areas where the equipment was most prone to failure. We found that certain components were failing more frequently than others, and that these failures were often preceded by specific warning signs, such as unusual vibrations or temperature fluctuations. Armed with this knowledge, we developed a predictive maintenance strategy that focused on replacing these critical components before they failed. It was a proactive approach, rather than a reactive one, and it started to yield impressive results. Equipment uptime increased, maintenance costs decreased, and productivity improved. But here's the thing, it wasn't just about the technical aspects of reliability analysis, it was about creating a mindset shift within the organization. We had to get the team to buy into the idea that prevention was better than cure, and that investing time and resources in proactive maintenance would pay dividends in the long run. It wasn't easy, of course. There were those who were skeptical, who argued that we were wasting our time and money on unnecessary maintenance. But we persisted, driven by a deep-seated desire to achieve operational excellence. As the results started to speak for themselves, the skeptics began to come around. They saw the impact that our approach was having on the bottom line, and they started to get on board. Morale improved, and the team began to feel a sense of pride and ownership in their work. Throughout the process, I felt a sense of excitement and anticipation. I knew that we were onto something big, something that could truly transform the way the organization operated. And as the results started to roll in, I felt a deep sense of satisfaction and fulfillment. It's a feeling that I've come to associate with operational excellence, the knowledge that you're doing everything in your power to optimize performance, to minimize waste, and to maximize value. And it's a feeling that I believe is within reach of any organization, provided they're willing to put in the hard work and dedication required to achieve it. In an organization, multiple stakeholders play a crucial role in ensuring that reliability analysis is performed to identify and mitigate potential failures, thereby achieving operational excellence. This multidisciplinary approach involves collaboration among various departments, including maintenance, operations, engineering, and quality assurance. First and foremost, the maintenance team is responsible for conducting routine maintenance activities, inspecting equipment, and identifying potential failures. They are the frontline defenders against equipment failures, and are well positioned to recognize early warning signs of impending failures. Maintenance personnel must be trained to recognize and report anomalies, which are then investigated and analyzed by reliability engineers. Reliability engineers, typically from the engineering department, are tasked with analyzing equipment failures, identifying root causes, and developing strategies to mitigate or eliminate them. They use various reliability analysis techniques, such as failure mode and effects analysis, FMEA, reliability-centered maintenance, RCM, and root cause analysis, RCA, to identify potential failures and prioritize maintenance activities. Reliability engineers work closely with maintenance teams to develop and implement corrective actions, ensuring that equipment is operating within design specifications. Operations personnel, including production managers and supervisors, are responsible for ensuring that equipment is operated within specified parameters, and that production goals are met while maintaining equipment reliability. They work closely with maintenance and reliability teams to schedule maintenance activities, ensuring minimal disruption to production. Operations personnel are also critical in identifying opportunities for process improvements, which can enhance equipment reliability and overall productivity. Quality assurance, QA, personnel play a vital role in ensuring that equipment is manufactured and installed according to design specifications, and that quality control processes are in place to detect and correct defects. QA teams work closely with reliability engineers to identify and correct design or manufacturing flaws that could lead to equipment failures. In addition to these teams, organizational leadership, including plant managers and department heads, must provide strategic direction and allocate necessary resources to support reliability analysis initiatives. They must create a culture that encourages collaboration, continuous improvement, and knowledge sharing across departments. Leadership must also establish metrics to measure equipment reliability, maintenance cost reductions, and productivity gains, ensuring that operational excellence is achieved and sustained. Furthermore, organizations may also engage external experts, such as consultants or original equipment manufacturers, OEMs, to provide specialized knowledge and expertise in reliability analysis. These external partners can provide training, conduct audits, and offer best practices to enhance the organization's reliability analysis capabilities. In conclusion, ensuring that reliability analysis is performed to achieve operational excellence requires a collaborative effort from multiple stakeholders across an organization. Maintenance teams, reliability engineers, operations personnel, quality assurance teams, leadership, and external experts all play critical roles in identifying and mitigating potential failures, maximizing equipment uptime, reducing maintenance costs, and improving overall productivity. By working together, organizations can create a culture of continuous improvement, drive operational excellence, and sustain a competitive edge in their respective industries.